All right, so another concept I want to talk about is return codes versus output. We've talked about this before in the past, but I want to demystify it a little bit. If I run a command like uname, what does it do? It's an external process. It runs on my system. My bash shell forks and execs. That's how processes are made on Unix and Unix-like operating systems. So it forks uname and it runs, and you can see that it outputs Darwin. So it outputs the name Darwin to standard out, but it also has a return code, and we can check that. We can check if it was successful or not. We can see that 0, it was successful. So cool, that's awesome. Now, if we were to do this in a script, let's do return codes. We'll make a new script called return codes. chmod +x, standard stuff, no trickery here. Let's run uname and let's echo $?. So the exact same thing, nothing magical going on here. We can see that we get Darwin and we get 0. Of course, we can also capture this. So we've done this before. There isn't anything new here. We can do this. We can do this. We could say code equals $? Remember, you want this to be right after the line. If I were to echo var here, I would actually get the return code of echo and not the return code of uname. So you want this up here, and then we can say output equals var, code equals code. So if we run this, we can see that output is Darwin, code equals 0. Hey, yeah, that makes perfect sense. And the important thing to remember is, what if we didn't want to use uname? What if we wanted to use our own mini program? Remember what mini programs are? myfunc. We can make our own function here. That instead of Darwin, we'll just echo YSAP for use programming, my channel name. How about that? We're making our own little operating system. And we return 0. Success. We explicitly return success. So now down here, we don't have to run uname. We could run myfunc. Same exact thing. It'll get it ran exactly the same way, and we can see output is YSAP, code is 0. Hey, that's really cool. If we change this to 45, we can see that, hey, we get 45 there. That makes perfect sense. If we were to change this to 300, what do you think we're going to get? Uh-oh, we get 44. Be careful with return codes. They are limited. It is an 8-bit integer. They can be between 0 and 255. So if I were to make this 254, it works. If I were to make this 255, it works. If I were to make this 256, it looks like success, even though we returned a number. Be very careful. You can return a number larger than 255, but it will get chopped off. You basically like have an overflow here. So like, this is not good. You'll get lost. So if you're writing code where you think, oh, I'll increment an error counter and just return the error counter as my code, that way the person will know how many errors there are. Well, be careful if their error code is divisible by 256, because then it will look like a success. So be careful with that. Let's just go ahead and let's be good, and let's make this return 0. So there we go. There's our mini program. It outputs YSAP and has code equals 0. Now, I've mentioned this before, but the standard output of the program is what gets captured by this notation. So we could change this. We could say echo this goes to standard out, and that is what will go to standard out. So if we run this, we can see that this goes to standard out and code equals 0. Hey, that makes perfect sense. This is the same as this, which is very confusing. We're going to redirect this to the file descriptor 1. 1 is standard out. This is what's assumed. It's just going to inherit it from my terminal. So this is exactly the same. But I show this notation to show that if I duplicate it, I can change this to standard error, make this 2. And what do you think is going to happen when I run this code? So we have this goes to standard out and this goes to standard error. Let's run this and let's see what happens. So this goes to standard error prints first. That's because this function is running first before the output is captured and stored in output. So this goes to standard error, which means it goes directly to my terminal. I can write to my terminal even before the function is done, but this is what got captured and what got stored in the variable. So this is important to note, because if you're running a program that just chooses to output to standard error or standard output sometimes, you actually have control over this. Like you, the programmer down here where I'm highlighting, you can control that, because I could say, hey, you know what? I actually want to redirect everything to dev null. You never really write code like this because this notation means you want to capture the output. Why would you throw the output out? But if I run this, you can see that we still get the error, but the output is empty because we threw the output away. You could put 1 greater than dev null. It's exactly the same. This is just very explicitly stating it, but you can do that. Now we could say 2 greater than dev null. We're going to throw out standard error, but we're still going to let standard out go through. So here, I'll show you that code real quick. And if we run it, you can see that this goes to standard out, but there was no standard error message because we threw it away when we ran the script, which is super nice. It's super convenient to be able to do this. there's another thing we can do. We can redirect standard error to standard out. So this is really cool. So now both will go to the same thing and we will get this wild output. Output is this goes to standard out, this goes to standard error, and the code is 0. And it's in the exact same order because they both go to the same place. The file descriptor has basically been duplicated over. So this is a really cool trick. There are some other things you can do here. Like we could redirect standard out to dev null, and then we could say, I want standard error to go where standard out goes. So this is gonna be a little bit confusing, but I will show you what I mean. We're redirecting standard out to dev null, but we're redirecting standard error to standard out. So what happens when we run this? We get nothing. That's because when this line ran, it already had changed standard out to dev null. So this means 2 is also being redirected to standard error because it goes from left to right. If we reverse these lines, things get a little bit gnarly. So let's put that line here at the beginning and let's get rid of it at the end. So now I've effectively reversed these lines. So now we're saying I want 2 to go where standard out is, which is just my normal terminal, which is just going to be captured by this. But I also want standard out to go to dev null. So in this case, we're going to get the opposite that you would expect. We get this goes to standard error. This is a way to capture just standard error and throw standard out. So you can do all sorts of finagling, all sorts of messing with things just by knowing this when it comes to return codes, capturing standard out, basic IO, all that stuff. So yeah.